Tutorial 5. Applying loading conditions and designing a single section using AnchorWall Software version 6.0. Loading conditions are applied to individual panels. In an effort to ensure the designer can easily navigate through the panels, the split-screen view shows the cross-section of the panel being selected and an elevation view indicating where the subject panel is in the wall. As with the Panels tab, holding down the Control key and using the left and right arrow keys, the user can navigate easily through the panels. On the left of the graphics, the user can input the loading information. The slope behind the wall is input in degrees. For broken back slope conditions, a crest offset is input. In our example, we have already defined these values using the crest geometry and crest offset grading information defined in the Stations tab. As such, these fields are now uneditable. As I toggle through the panels, you can see how AnchorWall Software iterates the slope and offset values between stations. For example, if at Station 1 we had a 3:1 slope, or 18 degrees, and at Station 2 we had a 2:1 slope, or 26.5 degrees, AnchorWall Software would gradually change the slope above the wall over the course of the panels between these two stations, as it has for our grading. If we hadn't defined the crest geometry in the Stations tab, we could just enter the slope in degrees and the crest offset for that panel. Just below the slope fields, live and dead load surcharges can be entered, as well as the offsets. Keep in mind that if you have a crest offset, the live and dead load offsets must be at least equal to the crest offset, or 0. If the slope and surcharges defined in the subject panel existed for the entire wall, we could just select Extend Left and Extend Right to copy this loading to all other panels on the wall. Alternatively, you can right-click on the panel and select Copy. Then, holding the Shift key down, select a group of panels you want to copy this loading to. Right-click on the selected group and hit Paste. The loads are shown graphically in both the section and elevation views. This is to remind the designer which panels have been looked at. We can see that the elevation view graphic shows that loading has been applied throughout the wall. Note that in our example, the slope above the wall was defined with the crest geometry, so it is not overridden when we copy the loading. Only the surcharges and surcharge offsets are applied. Now that we have defined our loading conditions, we can move on to actually designing the wall in the Design tab. The Design tab. The Design tab has been arranged to give the designer immediate feedback on the fly. Similar to the loading screen, the elevation and section views allow for easy navigation within the wall. To the right of the section graphic, AnchorWall Software provides a quick results screen, giving instant feedback on the minimum factors of safety for the various modes of failure. This screen also allows you to toggle between the static and seismic analysis, as AnchorWall Software analyzes both simultaneously. Below this, the results of the Internal Compound Stability Analysis, or ICS, are provided for both static and seismic conditions. The main purpose of the design screen is to include geogrid reinforcement in the wall, if applicable, and to check the stability of the design. If no geogrid reinforcement is added to the wall will automatically be analyzed as a conventional structure. For reinforced walls, the first step would be to select the geogrid reinforcement you want to use. The drop-down menu includes all of the geogrids you selected in the Reinforcement tab to be used in the design. The designer can use as many different geogrids in the wall as they like. However, it is always a good idea for the designer to weigh design complexity versus ease of construction when making these decisions. There are now two ways you can approach the design, manually or automatic. The Generate command creates a trial design that attempts to meet all the minimum factors of safety and empirical checks. The Generate function has been designed to automatically use up to 3 different types of geogrid, if required, in a trial design. This typically comes into play only in very high walls. The routine starts by trying the lowest strength geogrid in the reinforcement list. If this geogrid is insufficient, it will move to the next strongest geogrid in the list, and so on. However, the constructability of the wall should also be taken into consideration when generating a design. As a result, AnchorWall Software has provided a method to limit how tight geogrids can be spaced together. In other words, the designer may prefer to use a stronger geogrid placed every 18 inches vertically over having a weaker geogrid placed on every block all the way up the wall. This would be preferable from a constructability point of view, as well as probably being more economical. Using the toggle bar just below the Generate function, the user can influence the outcome of the geogrid generation by setting their preference for either using more layers of geogrid or alternatively using stronger layers of geogrid. This handy tool allows the designer to quickly and efficiently compare designs done with many layers of a weaker geogrid versus using less layers of the stronger geogrids. In this example, the wall height is insufficient to make a significant difference as the lower strength geogrid works at a reasonable spacing. Prior to hitting the Generate function, it is recommended to decide whether you want your panel to have uniform geogrid lengths throughout, or if you're going to allow variable lengths. If you wish to have uniform grid lengths, select this toggle. Generally, it is a good idea to start with the highest panel in the wall, which is indicated with a small black arrow in the elevation view. We will select the highest panel and run the Generate function. AnchorWall Software has created a trial geogrid reinforcement design that attempts to meet all minimum factors of safety and empirical checks for both static and seismic analysis. In this example, only the lowest strength geogrid was required, and we can see the geogrid type, length, and vertical position shown in the section view. We can click the Analyze Panel button on the shortcut key F9 and immediately see the quick results for this panel. We have the option of including the internal compound stability analysis or not by toggling the Include ICS field on or off. Generally, it is recommended that this remain off when you are just establishing your geogrid layout and trying different options to save computational time. Once you have finalized your geogrid layout with respect to internal and external stability, then turn it on and run the analysis again. The Quick Results table indicates the minimum factor of safety values for each mode of failure. Again, we can toggle between static and seismic quick results as both have been analyzed. If the ICS analysis is run, the results of the lowest 10 ICS radius point are shown. In this example, the Quick Results table shows that the factors of safety for all modes of failure meet or exceed the required minimums for both the static and seismic analysis, indicated by a series of green check marks. Modes of failure that do not meet the minimum factors of safety are shown with a red X. For a more in-depth review of the analysis and results, you can click the Full Output button or use the Ctrl-R hotkey. The full output provides the line-by-line calculations for every step in the analysis. The screen is divided into a left side, which indicates the mode of failure being reported, and the right side, which reports the calculations related to selected mode of failure. The full output is dynamic and interactive. When the user selects a particular mode of failure, say for example the pull-out calculations for a specific layer of geogrid on a specific block course, she can select that failure mode in the left side of the screen, and the related calculations are then shown on the right side. Note the right side is now divided into a top half and bottom half. The top half are calculations directly related to the specific mode of failure chosen, while the bottom half are general calculations that will apply to most modes of failure. Again, the full output can toggle between static and seismic analysis. If the ICS analysis has been run, the results are shown in detail below this. We can now close the full output screen to return to the Design tab. Within the elevation view, the panel is now shown to be green, meaning that it has been checked and passes. Note that all other panels in the wall are still blue, as they have been not designed or checked at this point. When using the Generate function, sometimes a designer might prefer that the geogrid start at a specific location from the top of the wall, despite what the top overturning check might say is allowable. Perhaps her experience has shown that it is prudent to have no more than, say, 2 blocks unreinforced at the top of the wall. In this case, the designer can select that uppermost block that she wants the Generate function to start placing geogrid. By clicking on the desired block in the section view, then right-clicking, a menu appears. Select Generate from selected course, and the Generate function will now start the trial design at the designated elevation. Note that the right-click menu offers all of the functions that appear on the left of the section as well. If the generated design is not acceptable to the designer, it can be modified a number of ways. To keep the geogrid length and spacing, but move the entire layout up or down, the Move Up or Move Down buttons will do this. To add or remove a geogrid from a specific course, simply double-click on that course in the section view, and it will add or remove a geogrid. To add a geogrid of specific length in a specific location, first click on the course you want the geogrid added in the section view. Then go to the Reinforcement Length field and enter the geogrid length. Once the value is entered, click the Add button and the grid will be added. Note that AnchorWall Software will check to make sure the length meets the minimum standards before it allows it in. If the AnchorWall Software Generate function came up with a geogrid length, but the designer wishes all layers to be longer, the new proposed grid length can be entered into the Reinforcement Length field, and the Edit All button is selected to modify all grids to one specified length. An example of this would be if a certain geogrid length is required for some other reason, such as global stability. To select a range of geogrids and edit them, select a block in the cross-section at the beginning of the range. Hold down the Shift key and select a block at the end of the range. As you can see, the blocks in the range are highlighted and we can now apply a change to them, such as the geogrid length, by hitting the Edit function. Once the designer is satisfied with either the generated design or the modified design, the design is analyzed using the Analyze Panel button, which is also the F9 hotkey. In the Quick Results screen, the minimum factors of safety for all modes of failure and empirical checks are shown for both static and seismic conditions as discussed earlier. We will now run the ICS calculation since all of our other checks have been confirmed OK. The ICS results, shown in the bottom right quadrant, provides the lowest factors of safety of the thousands of iterations performed in the ICS analysis. For each radius point, shown in column 1, the entry point is indicated, which is the location along the surface of the ground profile at the top of the wall. At the other end of the trial slip surface, the course through which it terminates is also provided. By providing this, the designer can again pinpoint areas of the design that need attention. So now our panel design is complete. Unfortunately, we have quite a few more panels that have not been designed yet. Not to worry. In the next tutorial, tutorial number 6, we will show you how to easily deal with continuing to design the rest of the wall quickly and efficiently.